Welcome back to the GODOT top-down shooter tutorial in 3D. In this video, we're going to be looking at creating our enemy. And we're just going to work with creating the actual enemy scene, and then we will go ahead and add some models later on. I haven't actually created the models for it. You could go ahead and create the models, the walk animation. Once you see this video and what the enemies do, you might get some ideas from that. It's important to just kind of try and see what you can come up with. So it's important you don't just follow along with everything, or all you'll learn to do is how to make the exact same thing that I'm making and not really understand how everything works together. Let's go ahead and make a new scene. This is going to be other node, and it's going to be a kinematic body. So we're going to use a kinematic body here, and I'm going to call it enemy. And I probably could call it enemy zombie. And zombie's an old hat, but they're an easy enemy to create. Now we need to have a collision shape in here for the rigid body. So we're going to add a collision shape. I'm just going to make it a, where we got it, a capsule shape. Now I really don't like that the capsule comes in sideways. It's kind of annoying. So instead, I don't want to rotate it and spend all that time doing that. I'm just going to use a cylinder, which actually comes in at a normal size. I'm going to move that cylinder up. Oops, I'm going to turn snapping on again. Move that cylinder up, and I'm going to make it a little bit smaller, like that, and that'll do. All right, so we've got our cylinder. It's about, make it a bit bigger, probably just to there. That's cool. All right, and then I'm going to add in a mesh. This is just going to represent the character while we create a 3D model for it. I'll put it on the zombie so it's not a child of the collision shape. And the mesh is just going to be a new cylinder mesh. Just going to keep it easy, keep it simple. And I'll go to transform and I'll scale it by 0.5 on the X and 0.5 on the Z. So that's going to give us a decent cylinder shape. The collision body is actually going to be a little bit bigger than it. And the reason for that is you'll see later on, there's going to be a lot of these things and we don't want them all just bunching up really tight together. You may want that, it's up to you, but I don't. So I'm just going to keep the collision or the collider just a little bit bigger than it. And then we're going to add in a second mesh instance. We'll delete these later, so I'm not going to worry about naming them. This one is going to be a prism. And I'm going to rotate this, not like that, rotate it that way. And if you remember, the negative Z, the negative Z, which is going that way, is the forward vector. So I'm just going to put this like this and maybe scale it in a little bit on that axis, just so I know which way the enemy is facing. That's not going to have a collider on it, that's just a mesh. Okay, so colliders are invisible, meshes are what you see. The next thing I want to have is an area node. This is going to be what detects whether the player is in that area, and we need to have a collision shape for the area node. With this one, we're going to go ahead and use a cylinder shape. And this cylinder shape, I'm just going to move it up, bring that up to there, and we'll scale that up pretty big. I'm going to scale it down to just be like this, but it doesn't actually matter. And I'm going to scale it up to a decent size. You can play around with that later on, but I'll just make this a little bit thicker. Okay, so we've got a cylinder shape. This is what our enemy is going to detect in here. And lastly, we need a ray cast. And this ray cast goes on there. And if we click on that, we want it to go along that Z-axis there. So we want 0 along the Y, and then maybe -10 along the Z. Maybe a little bit more. No, it only has to go with inside the area node. Okay, so -10. Now, to explain what's going to happen here, when the player enters or exits this area node, we're going to send a signal to the enemy that's going to say, well, turn in that direction, point towards the player. And then when they're pointing towards the player, we'll be able to check whether or not this here is intersecting with a wall or whether it detects the player. And if it detects the player, then we can make it move towards the player. If it detects a wall, then they won't do anything. They're pretty dumb enemies, these ones. In the future, I may look at doing some nav mesh, and I just haven't had the time to really fully understand how that works yet. So I'm just keeping this pretty simple at the moment. These are just dumb zombie style enemies, and I'm also going to make an enemy that backs away from you that while shooting, so a little bit smarter, tries to avoid you, and we'll get into that in a later video. So let's go ahead and add a script to this. Call the enemy zombie, and the script for this is pretty straightforward, but we just want to set a few things up first. If we go to area, we go to node, we want to set up body entered, I'll put that on there, and also body exit, and we'll put that on there. So we just have these two nodes, and they're attached to, we have these two functions, and they're attached to those signals. So when that signal fires, it's going to do this code. So let's go ahead and give some variables at the top here. We can delete that. Variable player. So this is going to be the player that they find. Variable follow player equals false. You could do this with state machines. Like I said, I'm just trying to keep things pretty simple at the moment. And I know state machines are really good. Finite state machines, where what you would do is declare in a variable or an enumerator what state the enemy is in, or what state the player is in. So they might be in search state, they might be in idle state, they might be in move state, and then you just have a switch statement or a case statement within your main function that goes, if the value, the state is this, then do this code, else do this code, else do this code. And it's really good, but it takes a little bit of time to set up, and we're just going with a really simple enemy here, moving on from the basic Python that we've already done. So let's just kind of stick with some things that we understand. And let's go ahead, and in the physics process, we'll add that in, func physics process. We're going to say if follow player equals true. We'll do this stuff in here. Now on area body entered, what we want to do with this one is check to see what has been entered, what body has entered. And so we can do that with body.name. If body.name equals player, then we'll say raycast.set enabled true. Follow player equals true, and player equals body. Okay, so we're going to set the player to the player variable that we declared before to whatever body is colliding, as long as its name is equal to player. Now that is a bit redundant, because we could just kind of find the node in the tree and do it on ready. But this case here, it's going to be, if you've got multiple players, we could do different things with that, and we could actually check to see if there's different names of the players. There's a lot of things we could do with that. I'm just keeping it simple here. And once again, this code is going to be very identical in the exit part, except we're going to disable the ray. We are going to follow player equals false, and we don't actually need player equals body. Now we can put some print statements in here just to make sure that it's working. Print found player. And then in this one, print lost player. Okay, let's go ahead. We'll save this as enemy zombie into scenes, and I'll go ahead and put one in my test level. So let's find that there, enemy zombie, put it in the level. It's comes in right there near the player. So let's go ahead and put it down here outside of the player's location to start with. And then I can move through here, and you'll look down in my, it says found player down here. And then if I go up here, lost player, found player, lost player. So it is detecting that the player has entered that location. Let's go back to the script, and we want to go up to this bit and add the code in here. So variable position, we're going to get the position of the player and make it look at the player. Equals player dot global transform dot origin. So this is going to get the player's global transform and get the origin of the player, and then we can rotate the enemy to look at that. So we're actually going to have to set where the player is going to be facing. So variable facing equals global. This is not player.global, this is global. This refers to the thing we're working at now, global transform.basis.z. And then we're going to say look at the position of the player, vector3.up. And then lastly, we're going to move and slide negative facing. Remember, it moves along the negative z. So we could actually just do this equals negative facing here. So facing times move speed times delta. Now we haven't defined move speed. Oh no, we did. That's 100. Facing times move speed times delta. And then we need to give it that vector, the floor normal, which is vector3.up. And this should be enough to get it to chase towards our player. So let's go ahead and test that out. It's not found the player yet. I'll move in here. It has found the player, it moves towards them, and then it's lost the player. Now in this case, the ray still shoots through here. So this is just going to keep moving towards us if it can. It gets blocked by doors. But we can make it so that it only moves towards us if the ray can detect that. So that's where we'll need something in here. We'll need if ray cast dot get collider dot is not equal to null. And if it's not equal to null, then we can check what the name of the ray is colliding with. If raycast dot get collider dot name equals player, then we can move towards the player. So we can't put this in an AND statement because if it is equal to null, then it's going to crash because it won't have a dot name, and then it will say I can't find what that is. So we just put it in a nested if statement there. So if it's not equal to null, then it will have a name because every object in Godot will have a name. And I can do that. And then if I close that or move out of the range of vision of it, it doesn't keep moving toward me. You can see it stops when the door begins to close. In the next video, we'll look at creating an enemy that moves away from us. And you can probably figure out how easy that's going to be, but we'll also add in the enemy firing at us. And I'll just create a simple bullet script. This will not be a hit scan weapon, it will be something that we can dodge, but it will be moving pretty quickly.